You know, we put a ton of trust in the science that keeps our smiles healthy. But what if that science, the very foundation of it, has some hidden cracks? Today, we're going to dig into some pretty unsettling questions being asked about the research that guides our dental care.
And really, that's the big question, isn't it? We're going to explore the pressures, the pitfalls, and the potential problems that can lurk inside scientific research, not just in dentistry but across the board, and what it all means for us when we're sitting in that chair.
So, to get started, we need to be clear on what we're talking about. When we throw around a term like bad science, what does that actually mean? Well, a lot of the time it comes down to something called scientific misconduct. Okay, so this is the official line from the U.S. Office of Research Integrity. And the key thing to get here is that we are not talking about honest mistakes. You know, stuff happens. This is about intentional deception. It's about deliberately cheating the system.
This kind of misconduct really boils down to three main types of deception. And you can remember it with a pretty simple acronym, FFP.
So that first F, that's fabrication. And this is probably the most shocking one. It's literally just making stuff up, inventing data out of thin air and reporting on experiments that never, ever happened.
The second F, falsification, is a little more sneaky. Here, the research actually happened, but the results get tweaked. This could mean cherry-picking only the data that supports your idea, conveniently leaving out the results that don't, or even messing with images to make things look more convincing.
And finally, the P is for plagiarism, and this one's pretty straightforward. It's stealing. It's taking someone else's words, their ideas, or their hard work and passing it off as your own without giving any credit.
So you might be thinking, how big of a deal is this, really? Well, one major study looked at all the scientific papers that had been retracted or pulled, and it found that more than 65% were retracted because of intentional misconduct. Think about that for a second. The majority of papers that get pulled are because of deliberate cheating, not honest mistakes. That's a huge problem for any field that runs on trust.
And what's wild is how creative people can get with this stuff. It's not just the big three we talked about. You've got things like salami slicing, where you chop up one study into a bunch of tiny papers to make it look like you've published more. Or citation cartels, where a group of buddies just constantly cite each other's work to make themselves look more important. And ghost authorship, where the person who actually did the work gets no credit. It's a whole ecosystem of questionable behavior.
Okay, so all this begs a really important question. Why does this happen? It's not always just a few bad apples. A lot of the time, there are major red flags that are actually baked right into the system of how we do research today.
And maybe the biggest driver is this culture of publish or perish. See, in the world of academia, your whole career, your funding, your job, your reputation, it can hinge on how many papers you publish, not always how good they are. And that kind of pressure can push even good people to start cutting corners. And then there's the other big one, money. I mean, what happens when the people funding the research, say a drug company, have a huge financial stake in the outcome? That creates a massive potential for bias, whether it's conscious or not. This kind of funding can actually steer what we even choose to study in the first place. So instead of research asking, what's the absolute best way to keep people healthy, it can start asking, what profitable product can we create? The focus shifts from public health to commercial products. And to see how this plays out in the real world, just look at this number, $11.5 million. That's how much the makers of certain pain drugs, gabapentinoids, paid out to doctors in just a few years. And what do you know? Studies found a direct link between doctors getting that money and them prescribing more of those drugs. It draws a pretty clear line. All right, so beyond the pressure and the money, there's another massive red flag, and this one's a little sneakier. It's all hidden in the math. It boils down to a question that seems simple, but is incredibly important. How many people do you actually need in a study to trust the results? This gets into something called statistical power. Honestly, the best way to think about it is like trying to look at a really blurry photo. If you don't have enough people in your study, your sample size is too small, the picture is just too fuzzy. You might think you see something that's not really there, or worse, you might completely miss an effect that is. Okay, this is where it gets just wild. Let me show you a real-world example from a dental study. To get a scientifically valid result for one of their key measurements, the math showed they needed a bare minimum of 282 patients. So how many did they actually use? 15. Not 200, but 15. That's not just a small problem, that's a gap so huge it makes you question the entire conclusion.
So after hearing all of that, from outright cheating to studies that are just way too small, it's really easy to feel a bit cynical, right? To kind of throw your hands up. But here's the important part. Is science capable of fixing itself? And the good news is a lot of people in the scientific community are taking this very seriously, and they're starting to build some solutions. Okay, let's talk about one of these problems, the file drawer effect. It's this tendency where studies that find exciting, positive results get published and celebrated. But studies that find nothing or that show a new treatment doesn't work, they get quietly tucked away in a file drawer, never to be seen. A really powerful solution is pre-registration. This is where researchers have to publicly state exactly what they're going to study before they even start collecting data. This basically forces transparency. You can't just hide the results you don't like.
Now, pre-registration is a huge step forward, for sure, but it's not a magic bullet. Fixing this stuff requires a much bigger shift in the whole culture of science. It's about moving toward more rigor and a lot more transparency.
And that path forward really has a few key parts. First is open science. No more secret data. Make everything public so other scientists can check your work. Second is way better training. Teaching the next generation about ethics and doing rigorous science from day one. Then there's reforming the peer review process to make it more transparent. And maybe the biggest one of all, changing the incentives. Getting away from publish or perish and building a system that actually rewards high-quality, careful research instead of just a long list of publications.
So where does all this leave us? The patients sitting in the dental chair. What are we supposed to do with all this information?
Look, the goal here is absolutely not to scare you away from your next dental visit. The vast majority of dentists and doctors are hardworking people doing their absolute best with the information they have. The real takeaway is that the information they rely on, the evidence itself, well, it's not perfect. Science is a messy, human process. It's constantly changing and improving.
At the end of the day, that's what science is, right? It's not a book of absolute facts. It's a process. It's a tool for getting a little less wrong over time. And understanding its flaws doesn't make it weaker, it actually makes us smarter. It gives us the power to ask better questions about new treatments, to ask about the evidence behind them, and to really think about what makes for good science. So the real question is, what will you ask?